Welcome to our lecture on the Earth's atmosphere layers. We're kicking off our unit here with some brief introduction to the atmosphere and the different layers so that we can eventually talk about the weather that we see here on Earth. We're going to finish up our quarter or our time before winter break studying the different processes in the weather. Later, when we get back, we'll study how humans are impacting the atmosphere and the weather systems. Our notes today look like this. You are going to find them on a Canvas link, though. They are actually going to be fill in the blank. So because we had to go online, we had to come up with a different way to do our notes instead of having the notebooks. So here's what we're going to do for now. This is going to be made available to you via Canvas. It'll be posted with this video. You're going to use the video just like you would with pencil paper to fill in the notes, but this time we've got an editable PDF to do this with. So I'll show you once you get the PDF open and download it onto your computer. It'll bring you into a PDF editor. You're going to use the lecture to fill in the notes. All you have to do is type and make sure you save it on the computer so that you can resubmit it as credit today. So unfortunately you won't be able to color these. If by chance you still wanted to print out the notes and take them by hand, you are more than welcome to do that if you have the resources at home. If what you've got to work with is a computer, this is what we'll do. You'll just type in the information that we go over. It might look a little wonky, but that's okay. We will make do with what we've got. Not what to save. Alright, back to our lecture though. Here's where we're going. Like I said, you're going to listen to the lecture, type it in. Let's get started. We've talked a little bit about this. For the most part, in our atmosphere, the most abundant molecule or gas in our atmosphere is actually nitrogen, which surprises a lot of people. One of the misconceptions is that we have mostly oxygen. We probably think that because we believe, or that's what we breathe, that's what we need, but actually there's only about 21% of our total gases in our atmosphere are oxygen or O2. For the most part, though, it is nitrogen. And that's significant. We don't really do anything with this gaseous form of nitrogen. You should have learned last year that the bacteria will fix nitrogen, make it into a more usable form that me and you can use, but for the most part we don't use this atmospheric nitrogen. We're interested in the oxygen though, because we need that to be able to do cellular respiration, aka breathe. But those are your most abundant gases, so all you need to do is type in those percentages right there. And then if we keep, I got a chart for you. So here's the composition of the atmosphere broken down for you in a pie chart. As you can see, nitrogen is the majority of what we've got in our atmosphere, second by oxygen. Argon, one of our noble gases there, makes up almost 1% of our nitrogen, or of our atmosphere. And then we have trace amounts of xenon, neon, hydrogen, helium, krypton, and carbon dioxide. But for the most part, it is nitrogen. So this is talking about air pressure on the side here. The closer you get to Earth, the higher the air pressure. You have about 14.2 square pounds of pressure on you at any given point because of all the air that is sitting on your shoulders. The closer you get to Earth, the higher the air pressure. So when you are up in a plane, if you are ever in a plane, the air pressure is actually less than if you were on Earth. This is because the force of the air pressing down on the Earth, aka the weight of the air, like I said, is about 14.2 pounds per square foot. And then the farther you get from the Earth, the lower the air pressure. So just know that if I was a rocket re-entering Earth's atmosphere, I would increase in pressure as the ground came closer and closer. Okay? Next, starting with our layers of the atmosphere. There are debatably 4 or 5. We are going to talk specifically about 5 of them, give or take 1. We'll talk about why that's that way in a second. Okay, so we're starting at the very closest to the Earth's surface. This is the troposphere. It spans from the Earth's surface to about 5 or 9 miles above the Earth. This is where all our weather happens. As we are going up in the troposphere, we see a temperature decrease, meaning that the further up I go into my atmosphere, when we're in the troposphere, the colder it's going to get. This is where 99% of our water vapor is in this region, meaning that this is where weather happens. So this is where our clouds form. The clouds are able to block out the sun's heat in some cases, or not if it's not a cloudy day. But this is where weather happens. So any kind of like hurricane we get, thunderstorm, anything like that, tornado, it's all happening in the troposphere. Okay. And then with my little weather balloon right there and hot air balloon, as well as my plane, the planes will typically fly right at the top of the troposphere or even up into the next layer, which we call the stratosphere. This graph is something that you're going to see again and again. So you've got distance from Earth's surface right here. In kilometers on the left side and miles on the right side, which you can't see the miles. And then the bottom or x-axis is tracking our temperature. 0 is right here, degrees Celsius, and gets very cold this way and warmer this way. When, as you can see, as we get further up, the yellow line indicates temperature. The temperature is actually decreasing the further up you go into the troposphere. Now, in contrast, when we are in the stratosphere, which is about 6 to 18 miles, that's debatable. Some sources say 31 miles, but 6 to somewhere in the 20s range miles from the Earth's surface, we have our stratosphere. This is where our ozone layer is. Now, we're going to talk about ozone in two contexts this year. One is the ozone that's found in the stratosphere, and it's very helpful for humans. It protects us from the harmful UV rays. So if we didn't have, that's when we talk about like the hole in the ozone layer. That's what we're talking about, this layer that's very protective. It protects us from those UV rays and blocks out some of the sun's radiation from us. So when we're talking about this ozone, it's good because it protects us from harmful UV rays. After break, we're going to talk about the ozone that is happening when we're releasing chemicals like carbon, chlorofluorocarbons. We'll talk about those too, but those are increasing something that is bad in terms of ozone. So we've got two types. So this is the good type. We want this ozone. Like I said, planes fly here. Typically, the jet stream is found right where it says tropopause right there. The jet stream is found right there, so, and just a little bit above as well. This is where our jet planes will fly. If you go up into an airplane, it's typically not very turbulent right there. It doesn't have a lot of ups and downs as far as wind goes, so that's a good place for our planes to fly, but they don't fly much higher than that. If you can tell, again, we're tracking that temperature line right here on our graph. As you go higher up into the stratosphere, we are getting warmer, although debatably warmer. It is still freezing. That line never crosses 0. Okay, here's our mesosphere. This is the next layer. It is found between 18 and 30 miles an hour, miles above the Earth's surface, though I said that's debatable by scientists. Some people say, and even our graph right here tells us that it's further than that. It is 31 to 53 miles from the Earth's surface. Meso means middle, so this is kind of like our middle of our atmosphere we'd like to think of, even though we have 2 layers before it and only 1 to go above it, but that's okay. It's pretty thick. If you are tracking that temperature line again here on our graph, we see that the higher we go through the mesosphere, the colder it gets, actually reaching about negative 100 degrees Celsius, which is freezing. We wouldn't survive there. The air is thinner. Actually, the further you go up into the layers of the atmosphere, the thinner your air is, meaning that there are less molecules of air in there. We get our meteors are burned up here. So if anything were to try and enter the Earth's atmosphere, they would burn up by the mesosphere as long as they are small. Mesosphere is, there's not too much exciting things to say about the mesosphere. It just really is. Scientists haven't thought too much about it or haven't made very many discoveries, but the important thing to remember here is this is where our meteors burn up. If we keep going to our thermosphere now, thermo means heat, so we are seeing a distinct change between temperatures. It can go anywhere to about freezing, just a little bit less than freezing, or as you travel, let's look at our graph again, as you travel up into the thermosphere, it is actually getting way, way warmer. It can reach up to 2,000 degrees Celsius, which is about 3,600 degrees Fahrenheit. So really, really, really warm. Remember, boiling point for Celsius is 100 degrees Celsius, so this is even further than 10 times, because 10 times 100 is 1,000, so it is greater than 10 times past the point of boiling, so it's very, very hot. This is where our aurora borealis happens, the northern lights, those green lights you might see if you go up north to visit. And this is where those happen. Very, very pretty. It's more like outer space here than it is down in the troposphere. So the further up we're getting away from the Earth, the more our molecules are becoming thinner. There's just not that many oxygen and nitrogen molecules up there. It's also, you're starting to not have the effects of Earth's gravity as much right here. So it's definitely pretty different. This can span from about 53 to 372 miles away from Earth's surface. Our stats here on your paper say 30 to 250 miles out of the atmosphere. And then our last layer we're going to talk about, remember here's our graph again, the thermosphere. Our last layer is the exosphere. So the exosphere actually tags on to this very end of the thermosphere up here. It extends into space. Exo means out, sphere is like round, so out round. It means outer space pretty much. The air is extremely thin. It's almost like a vacuum. So the exosphere is pretty much outer space. So it's really, really thin air, meaning there are not a lot of molecules. And it's not like a distinct boundary between the exosphere and space. It's kind of a blurred, or it fades into space. And actually, I discovered through some research that the air is leaking out of the atmosphere through the exosphere at a very small amount, but it is happening. So our air molecules are just slowly floating away into space. Not a huge deal because there's not that many out there anyways, but it's there. An important note, some scientists don't consider this part of the atmosphere, but for the purposes of our class, we are going to. The last thing I wanted to talk to you about, so there's this thing called the ionosphere, and that is not considered one of our normal layers of the atmosphere, but it does happen. Let's see if I can find the picture for you guys. It does show up. Okay, so if you're looking at this graph again, looks familiar. You got troposphere, stratosphere, mesosphere, thermosphere, and then exosphere, right, is around in here. So our ionosphere is actually 3 little distinct layers. This is where the sun's rays have charged some of our molecules in the air and left them either having too many electrons or not enough. And it's just a pretty significant thing. The only reason we discovered it was because it was messing with radio signals. And I think that's pretty significant. It's just the nature of science that we often don't discover things, or we don't mean to discover things as scientists. Often we just stumble upon them and then try to explain them, and that is pretty much the nature of science. Okay, I hope you enjoyed the lecture. This is it. Turn in your sheet after you finish typing everything you need to. Have a great day. Goodbye.